Namaste and welcome to lecture 5 of decimals. Today we will be doing like and unlike decimals. Okay. Before starting with like and unlike decimals, we would learn what are decimal places. Now the number of digits on the right of the decimal point in a number is known as the number of decimal places. Now see, what does this mean? The number of digits on the right of the decimal point. Suppose we are having a number 5.68. Then how many digits are there on the right of this is the decimal point? On the right means this two. There are two digits. Yes, in a number. So that this is known as number of decimal places. As there are two digits, we can say that there are two decimal places. Suppose we have a number 6.893. Now on the right of the decimal point, so this is the decimal point, and on the right means this. How many digits do we have? Three digits. So we can say here there are three decimal places. Let us take a number 2.5698. There are four digits after the decimal point, that is on the right of the decimal point. So we can say that there are four decimal places. This is the meaning of decimal places. Now we will start with like and unlike decimals. Okay. Let us know what is like decimal and what is unlike decimal. Now decimals with the same number of decimal places. See, these are nothing but same number of decimal places are called like decimals, and decimals with different number of decimal places are called unlike decimals. Let me take an example of this like one first. Example 1.2, 3.1, 5.6. Here after the decimal point we have one digit. Okay, so it is called one decimal place. As all the three decimals have same number of decimal places, they are like decimals. Okay, got it? Because the decimal places are same, so they are like decimals. But if the same example I take 1.21, 3.1, 5.639, all the three decimals have different decimal places, so they are unlike decimals. Okay, now how can we convert this unlike decimal into like decimal? These all are unlike decimals. Let us convert them into like decimals. Now for that we should note one thing. that by adding any number of zeros after the extreme right in the decimal part of a decimal number, then what will happen? It will not change the value of the number. Okay, does not change the value of the number. Meaning of this is, if 2.1 is there and we write 2.10 or 2.100 or 2.1 and 3 zeros, then the value of the number 2.1 will not change. Okay, so converting the converting the unlike decimals into like decimals, we will make the decimal places same. What will we do? We will make the decimal places same. That is, we have to add zeros in that. Okay, suppose the unlike decimal is here and the like. See, 7.05 and 4.2. These two are unlike decimals. To make them like 7.05, there are two decimal places. So now to 4.20. This will also have two decimal places. So now we can say that they are like decimals. So we have to add 0 at the extreme right. Suppose it is given to us 9.5 and 0.436. These are both unlike decimals. What will I do? 9.5, because here it is one decimal place. Here it is three decimal place. To make this 3, I will add two zeros. So 9.500, 0.436. Three decimal places. Yes. So now these two are like decimals. Okay. This way we convert unlike into like. Suppose 8.6, 4.75 and 9.325. All these three numbers are unlike decimals, okay, because they have got different decimal places. So to make them like, what will we do? We will make all the decimal places equal by putting zeros at the extreme right. So how will we do? 9.325, three decimal places. So to make 4.750, three decimal places. And 8.600, again three decimal places. Now all these three numbers are like decimals. This way we convert unlike decimals into like decimals. Okay. And also numbers which are obtained by inserting zeros. See, here we can have one more thing, that equivalent decimals. What are equivalent decimals? See, numbers which we obtain by inserting zeros after the extreme right digit in the decimal part. Okay, these numbers are equivalent decimals. Okay, so now these all the three are equivalent decimals because having we are adding zeros. See, suppose 0.3 is equal to 0.30 is equal to 0.300. No matter you add zeros, the value will not change. Okay, after adding zeros, value will not change. Okay, so I will say that numbers obtained by adding zeros, or not adding, we can say inserting zeros. Let us write by inserting zeros after the extreme right. Extreme right in the decimal part of a decimal number are the equivalent decimals. Okay, are known as equivalent decimals. That means 0.89, 0.890, 0.8900, or 0.8900. Even though here we are inserting zeros, yes, as we go ahead we are inserting zeros, but value will not change, and they are called equivalent decimals. Okay, so this was about the like, unlike, and equivalent decimals. I end my lecture over here. In the next lecture we will understand more, and then we will move on to comparison of decimals. So thank you very much. We'll meet in the next lecture.